Hello everyone. So today we're going to talk about intermolecular forces, which are just forces between molecules when we contrast it with intramolecular forces, which would be the forces within a molecule itself. And the first type of intermolecular force we're going to talk about is hydrogen bonding. So a lot of people mix up what hydrogen bonding actually is. And so we're going to go into depth of what you need to know for your MCAT and your DAT. So there's only 3 atoms that you're going to see on your DAT or MCAT that can hydrogen bond. And that is going to be a hydrogen that's attached to a fluorine, a hydrogen that's attached to an oxygen, and a hydrogen that is attached to a nitrogen. All this really is a dipole that is very strong. And it's important to know that hydrogen bonds are the strongest of the 3 intermolecular forces we're going to be discussing. And I'll go ahead and draw an example here. We'll use your typical water molecule. Alright, so this oxygen is more electronegative than this hydrogen here and this hydrogen here. So this hydrogen is going to have a partial positive, and this right here is going to have a partial negative. So when you have another water molecule, you also have the oxygen with a partial negative and the hydrogen with a partial positive. And what's going to happen here is this oxygen is going to have an attractive force with this hydrogen. And the reason for this is because the hydrogen has a partial positive charge and the oxygen has an electronegative charge. That's also a partial electronegative charge. Something on the DAT in particular that they like to trip students up on is you have a question. Let me put on my pen. You have a question. You'll have a carbonyl, and then you'll have another carbonyl. Now you tell me, can these molecules hydrogen bond with each other? If you said yes, you would be incorrect because there is no oxygen that's attached to a hydrogen. It's the carbon instead. So you can have dipole moments within these molecules, but you will not have hydrogen bonding. Now, if you were to get rid of one of these carbonyls and instead add a water molecule, now, would you have hydrogen bonding? Yes, you would. So, this partial negative here, this is a partial positive here, and you're going to have a form of attraction between these 2 molecules. So that's an important fact to keep in mind, and remember, hydrogen bonding is the strongest intermolecular force you're going to face on these tests. The next type of intermolecular force we're going to talk about is a dipole-dipole interaction, which I have drawn an example below. All this is a difference in electronegativity between these molecules, and you can see here that the bromine has this partial negative and this hydrogen has this partial positive. So there's going to be some attraction between the 2 of them. And this is going to be your second strongest intermolecular force you're going to face on the test. The weakest of the intermolecular forces we're going to talk about are the London dispersion forces, also known as van der Waals forces. So it's important to know that all molecules have these van der Waals forces between them. It's just that if you have nonpolar molecules, this is the only intermolecular force they have. It is important to know that the larger the molecules are, the stronger London dispersion forces they have. And all London dispersion forces really are, it's just a weak and temporary attraction of molecules, and it just has to do with electrons moving in different directions and a force between a partial positive and a partial negative charge coming into play. Now, since we've discussed these intermolecular forces, there's a side note you should be aware of before you step into your test. Ionic and covalent bonds are much stronger than these intermolecular forces. So if you come to your examination and they start asking you different properties of molecules and they want to know which one has the most, whatever, then you're going to go down the line, and if there's an ionic or a covalent bond in there, it's going to be stronger than one of the intermolecular forces. And some of the properties that they're going to ask you about, I'm going to discuss right now. So when you have a stronger intermolecular force, like hydrogen bonding, rather than your van der Waals forces, it's going to have a higher melting point, boiling point, viscosity, and you know what this last one is? Surface tension. And if you have a lesser intermolecular force, let's say van der Waals forces or dipole interaction rather than a hydrogen bond, you are going to have more, or you're going to have less of these different properties. Now, when it comes to vapor pressure, something that is really important to keep in mind is that if you have higher intermolecular forces, you're going to have a lower vapor pressure, and there's a very good chance you will see this on test day because it's a very simple point that's easy to forget for students. And that sums up this lecture. If you guys have any questions, please feel free to comment, and I hope you guys have a nice time studying and good luck with everything.